Okay, let's record. So I started recording. You can.
Sandeep, I wasn't exactly sure what to do, but I just went through the.
I'm sorry, I did not get. What is the question?
Are you able to hear me?
Yeah, I'm able to hear, but I did not get your question.
Okay, I was just taking some. Hang on a second. Yeah, Sandeep. So I wasn't exactly sure what what was needed. So I went about the motion of putting together code based on my interpretation. So,
So it's more about understanding the code. I mean,
okay.
understanding the data. Sorry. Yeah.
Understanding the data. So I've
Yeah.
done my best. I don't know if it aligns with what you were expecting or what you're wishing to see. Or what.
No, that's okay. We will get those corrected
Okay.
if needed. Okay. So it's more about the statistics part, which means the descriptive as well as the inferential stats. What are the
Yeah.
inferences you can get, and what is the what are the assumptions that you have on the data, and what is the after applying the statistics, what did you understand? So that is more about statistics actually. So for
Okay.
example, if you see here, uh, maybe if the city is if it is a city, I expect low fat content uh, not to be purchased much, because in cities most of the fat content is consumed in cities only. So I expect fat content, the consumption of fat related food products to be high compared to the rural area, or even outlet size. Based on the outlet size, I can expect the sales to be more, something like that.
Okay.
So whatever the assumptions, whatever you thought about, that is fine. Uh, but I just wanted to find out how well you are able to find out the inferences, or
Okay.
find out the, and I mean, most importantly, it's not just about the inferential statistics. It's more about how do you understand the data.
Okay.
Okay, because until now I just gave you the questions and you just answered. This one is like I just gave you the data and you have to answer me. So that is more like that.
Okay. So I started with importing the spreadsheet.
Hmm.
I went with the description first to look at the different descriptive elements like mean, standard deviation, percentile. So I use the describe function here to come up with. Basically, I was interested more in this part, the mean of sales.
Mm.
So
So
then I
yeah, mean of the sales is like $2,000.
yeah
So
$2,000
one of
and
the thing I want to understand is there is 50%, right? Do you understand that number? No, I think you should be able to, but
this is IQ. Sorry, the percentiles.
percentiles, right? So the
Percentile is basically
50th
median.
percentile. Anyway, I'll ask those questions later after your demo. Okay, maybe that
Sure.
is better instead of interrupting.
No, that's fine. This is my median, the 50% value here.
Mhm.
One thing I noticed is almost the standard deviation is almost 75% of the mean itself. So it has a very wide standard deviation.
That's right. Yeah, correct.
So that part was good. And the spread, which is the range between the min and max,
Mm-hmm.
33 was 13,000.
Mm. Lot of spread.
Yeah.
Okay.
And And then I did a dataset covariance table
Mm-hmm.
where my covariance is. So in that table, I got a cue that between the sales and MRP, there seems to be a large covariance.
Sales and MRP, there is a lot of covariance. Okay.
Covariance. So the
Very much
variable,
related.
yeah, very high. The next followed by um, this one item. There's a negative correlation between sales and establishment.
Mm-hmm.
Other than that, other covariances were much smaller in number.
Mm. Okay. Now, if you see one thing you can notice here, item sales versus MRP, the covariance is too large. Did you understand why the different? Why the such a big covariance is there? If you compare any other number, it is not such a big number.
Yes, so what I noticed was I went back to the data to check. Right? So I did a quick pivot table here and I looked at the graphs. So
Mm-hmm.
what I noticed was the higher the MRP tight in a particular area, the larger the sales.
Mm-hmm. It's not just that. The reason for covariance being, if you remember our discussion, covariance is uh, related to the scale of the measurement. If you
True.
change the scale of the measurement, you'll see something else. For example, in this case, item MRP is in rupees, I think. And if you convert that MRP into dollars, you'll get a different covariance value. That is one thing. And second thing is sales is a bigger, it is in a bigger scale. If you just mentioned that, right?
Yeah.
The scale is much larger. The range is much larger. Max minus
Yeah.
max. Because of that, MRP, the covariance is more. But unfortunately, you cannot see this and get a good picture. So always go with the correlation, the one that you had below, and then give the inference. Anyway,
Right.
you can
So
carry on. Yeah.
right. So I went to the correlation because I briefly looked at this number. Are you able to see my screen, right?
Yes, yes, yeah.
I looked at this. So this was a queue for me, and the other numbers were this one was a queue for me.
Okay.
So I wanted to get more insight, so I did the correlation of the entire data set.
Mm-hmm.
So in that, if you notice it, there's a negative correlation. The biggest correlation again was showing up was 0.56
Mm-hmm.
compared to any other correlation factors. There's
Yeah.
a negative correlation between visibility and sales, and of course visibility and sales. So you see this minus
Yeah,
point.
that is a, you can see the lower triangle. That's it.
Yeah.
Okay.
Yeah.
But most of them are very less, right?
Yeah. Most of them is one of the only part that was either it can be closer to -1 or +1. That's when it becomes significant.
Right.
Anything closer to 0, there's not much correlation pretty much.
Right.
So then I move on to basically allocating variables to series. Data set MRP based on this numbers.
Mm-hmm.
These three were selected based on correlation values.
Okay. What are you doing here?
I'm just allocating.
You're converting it into series and just
Yes,
doing the
I'm
same
converting
correlation.
basically item sales went into sales, visibility into visibility, MRP into MRP. Basically, this allocation, nothing much.
Okay, okay, sure. Yeah, you can run it. Vijay, you also, if you have any questions, you can also ask. It's more like a discussion than a class today.
Okay, Sandeep.
Yeah. Yeah, carry on. Zain.
Yeah. So for different combinations, printed the covariance followed by the correlation. A combination so that as we progress through the code, gives sort of a guidance on what to follow.
Mm-hmm. Okay.
So these combination between sales and visibility. Okay, we have 0.12 in negative correlation. So one data, if sales is increasing, visibility numbers are going on the opposite direction.
Yeah, it is the other way because we are interested in sales. So you can say as visibility increases, sales are decreasing, which is unfortunate because on the store, if it is visible, sales should
Yeah.
not decrease, which is not what we expected. But there is a slight negative correlation. You can say it's not much because it is
Right.
only 0.12.
Right. The expectation is, as the visibility index increases,
Sales should go increasing.
sales should increase.
Yeah.
Yeah, at the eye level, it's more visibility. Obviously, the sales should be proportional.
Yeah. Which are something that only numbers can tell, only statistics can tell.
Right.
If you say my visibility quotient is more, and why did my sales go wrong? That is something only statisticians can say. Anyway, yeah.
Okay. And then, of course, as we saw earlier, there's a high covariance between sales and retail price, and also there's high correlation. So these two are two variables of my interest.
Yeah.
Sandeep, I had a tough time creating plots because it kept running out of memory. Even though I increased it by 10 power 12, 10 power 13, it still kept giving me that error. Finally, only this plot worked.
Oh, is it?
Yeah.
Oh, somehow it is working fine for me. Maybe you can show it someday.
Yeah.
We'll try to understand. I don't know.
I went here, I changed it multiple times. Right now, I don't have history because I just started this again.
That's okay. That's okay.
So then I went and just did the sales box plot. See the mean, like 2081, as we discussed. It's falling here, but there are a lot of outliers after 6,000 odd. Everything it's like a long tail.
Yeah. So above $6,000 outliers, it looks like.
Yeah.
Okay. So what you can do here is, if there are too many outliers, what you can do is first you can just take a count. Any sales above 6,000 or 6,100, I'm not sure the exact number here, but it will be around 6,000, right? Maybe anything above 6,000. Just take a count. If it is like 30% or 40% of the entire data set,
okay.
Then what you can do is you can take your data set into two parts. You can break your data set into two parts. First part, analyzing sales less than 6,000. Another, analyzing sales greater than 6,000. What I mean to say is you can do two regressions. That is also fine.
I didn't get the part of two regressions. So I understood the part where you're separate.
So predicting sales is a regression, right?
Yes. Yeah.
So predicting sales is a regression. What you can do is you can try to do two regressions. Anything sales greater than 6,000 or less than 6,000. Or the other way is you can directly remove all the outliers and then do a single regression.
Okay.
Okay.
What is your guidance about the 30% mark? So if this data is 30%. You mentioned that.
Yeah, 30% is also fine given the data size is more. So for example, I'm not sure how many data points we have here. I think 300.
8,500.
8,000. Okay, 8,000 out of 8,000. If 3,000 data points are outliers, is it 8,000? I'm not sure. It is 8,000 or okay, count is 8,000. Okay, so out of that 8,000, let's say 3,000 is outlier. You're still fine. Okay, remove all the 3,000. Let's say the data points are very less. Let's say it is only 100. Now, removing 30% out of 100 is very costly compared to 30% out of 8,000. Because you already have lesser information. then what you have to do is you have to live with those outliers. Maybe instead of 1.5 into IQR is the standard, right, that we generally go with.
Yeah.
Instead of 1.5 into IQR, maybe go for 3 into IQR. Just increase your width of your whisker.
Okay.
Okay, remaining ones you can remove.
Okay.
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 Yeah, 2 regressions and all, it is confusing. Don't worry about that. Okay, anyway, you can carry on.
From this point on, it's where the more confusion starts. Obviously, because I wasn't sure what exactly how to tread into inferential statistics. So I took guidance from your classes and went from there.
Okay.
So what I did, Sandeep, is I did two things. So one is I did a confidence interval of the entire population. So I got these numbers. The confidence interval being 2150 to 2211. So compared to the sales mean. Then what I did random sampling, about 500 each, and every time I would come up with.
Yeah, every time you'll get a different. You have to import it. Yeah. Every time you'll get a different confidence interval. Is that what your question is?
Yeah.
Yeah, because you're random sampling, that is how it will be. But why are you random sampling? Is there any reason?
I just want to see if like with the replacement equal to true, I wanted to just see if I for single mean whether we are sampling within across the entire data set, if how much it changes. I was just curious about it.
Okay, so here random sampling of confidence interval will not give you anything actually, because random sampling of confidence intervals will give different confidence intervals at every time. But if you see the true mean, let's say out of all the 8,000 samples, go with the sales dot mean. Can you show me the sales dot mean? I think that is 2181, right?
Yeah.
So if you take many confidence intervals like this, all those confidence intervals, at least 95% of them will contain the true mean, which is 2181. That is what is the meaning of confidence. I mean, this taking random sampling and then doing confidence intervals. Did you get what I'm saying?
Yeah.
Out of 100 samples, such samples, theoretically, it may be 1 or 2 here and there. But theoretically, if you are taking alpha equal to 5%, it means that out of 100 samples, 100 such samples of size 500, it is not 5,000, right? Or is it 5,000?
No, I just changed it to 5.
You just increased. Okay, that's fine. If you increase, it will be more accurate.
Yeah, because you have said once you increase n, obviously confidence interval decreases.
The size of the confidence interval decreases. That's what we realized, right? So the moment you take a random sample of 500, what happens is you are getting, so assume that your entire sales of 8,000 points is your population, because you are taking a sample from that. Assume that the sales of 8,000 data points, it is your population. You are taking a sample from it, sample of 500 from it. Now, every time you take a sample of 500, you get a confidence interval, and that confidence interval is going to contain the true mean. The true mean means the population mean, sales mean.
Right.
So now if you see 2181 is within the confidence interval that you created. Maybe you can run it again. We can see if it is next time it is coming or not. This is more of a theoretical standpoint. In reality, you may not need, but it is good that you did. So for example, even now 2181 is within this interval.
What I struggle with is how big this sample should be.
it should be good
Oh,
enough. There is no theoretical limit for that.
okay.
So, but you can say for 8,000, maybe 1,000 or 500 is good number. But if you say 50, then it is not a good sample out of 8,000 population. So there is no theoretical limit there.
So I went with about 5% mark. I was thinking initially 10% might be a good sampling window, but then
Yeah,
I
5-10% is good enough actually. Whatever you
Okay.
did is correct. But if
Okay.
you go to that size and keep it 5 instead of 500, I don't think I doubt that this confidence interval is going to work very well. Can you change it? Now that you asked,
50.
5 instead of 50 also,
Okay.
maybe 5. Yeah, it's still doing a better job. It's not a great job, I think,
Yeah, this one changed.
but it's still doing a better job.
Yeah.
But I would say like 1% or 5%, it is much safer approach. Like,
Okay.
let's say if you take 50, probably it will do much better.
Yeah.
This could be one of the 100 samples. Can you run again? So 5 out of 100 samples, you'll get a wrong answer. Oh my god, this is gone.
5 out of 100 samples.
Yeah,
Yeah.
that's what it means by confidence interval with 95% confidence interval. What it means is out of 100 such samples, 95 samples will get correct answer.
Yeah.
Okay. Hope this is clear now.
So when you do the 5, Sandeep, does it have any correlation with the 5% error? The data, it doesn't, right? To take,
I'm sorry, I did not get your voice broke.
no, what my question is, with 5% error component, alpha is 5%. Right? Does it have any bearing on the sample size? So you mentioned 5% should be good enough. So when I increase it to 500, it seems to be good, giving me a good number.
No. So it is only a random guess. Most
Okay.
of the times it is happening at 5%. You remember when I said empirical formulas and derived formulas?
Yeah.
So this number, whatever I gave, is also empirical based on my experience. No one gave that number. If you go to any theory, you'll not get any theory saying this is an accurate number. They'll just give you some approximation. There are theories. It's not. I should not say that there is no theory which will say sample size is not. I mean, I cannot derive the sample size, accurate sample size, but that is not needed for you actually.
Okay.
You can just assume that it is like 5 to 10%. It will do generally very good.
Okay.
It's more like if it is less than 5%, let's say if it is only 1% or 0.001% or something, you're not getting the enough data to get the evidence, right?
Yeah.
So if your evidence is not good, then your result will also be not good, obviously.
Yes. Sir.
So that's why I'm saying 5%.
Okay.
There's no reason why confidence interval and this 5% are not related. They're irrelated.
Okay. Okay.
Okay.
Got it, sir. Yeah.
Yeah. Then you did some test of hypothesis. Okay.
Yeah, I did test of hypothesis, then I just gave it as a precursor.
So what was this test about?
Here. So
Okay.
I'm basically saying, okay, if mean, whether mean is not equal to 2181, or I'm just testing the mean part.
Okay. Is the population mean same as the sample mean that you got?
Yeah.
Okay. So what is the answer you got?
So I got p-value is very high.
Hmm.
So except mu is equal to 21, it's just basically a test of what we saw in discrete statistics. So
Yeah.
basically just a confirmation.
So you're just saying, you're just trying to understand whatever sample mean I got, is
Yeah.
it same as the population mean or not?
Yeah.
Okay. Yeah, that is a good test. Yeah. It looks like population and sample mean are same.
Yeah, because the data set I consider as the entire thing, right?
Hmm. No, that's not the reason. It is statistically proven that whatever the 8,000 sample sales data that you have
Yeah.
is equal to some population mean. It will be definitely more than 8,000, but you don't know exactly how much it is. Okay. Are you
Okay.
clear with this interpretation? Here, whatever you did, here the sample size is 8,000. It's not 500.
Right. That's what I'm saying. The
Hmm.
sample size is not the 500 I took. I took the entire the population data I have and
No,
treated
no,
it
no.
as.
That is not population. That's what I'm saying.
Oh,
Once you
right.
enter inferential statistics, whatever you give to the algorithm or the test of hypothesis or any technique, whatever you give, it is sample. It should be considered as sample only. Even if it is 8,000, it is sample. There is some bigger population which you never know, which has some mu. Is that mu same as whatever sample I have? That's what I'm testing. That's what you're testing here. Is that clear?
Yeah, it is clear, Sandeep. Then in that, what I did, I went through that, broke it down into smaller samples and redid the.
Okay. Actually, so let me correct you here. You don't have to break always. The reason I took a sample is because anyway I don't have the bigger population, right? Something bigger than 8,000 sample.
Yeah.
So what I did is I thought 8,000 is my sample, is my population, and I took some random samples to show you some of these theoretical concepts like central limit theorem and all those things.
Okay.
Okay, you don't have to take random samples every time.
Okay.
Okay, this is not needed at all. No need to take random samples and take test of hypothesis, all those things.
Okay.
Okay.
Right. Yeah, of course. I mean, obviously, I come with different p-values every time I test it. So.
Yeah, that's correct. Anyway, p-value is high. You don't have to worry it is 98 or not. Anything more than 5% is p-value high.
Right. So yes.
Okay. Okay. Zahir, are you there?
Yeah. 1 second.
Okay.
So then what I went about doing, Sandeep, is I wanted to do a subsetting of outlet type.
Mm-hmm. Okay.
I not see it. 1 second, Sandeep.
Okay. You forgot what you did?
No. It's basically, I took different supermarket types.
Mm-hmm.
Type 1, type 2, type 3.
Yeah.
And I did test of hypothesis across item sales and supermarket type.
Okay.
So basically, that's what I'm trying to show here. What I did was, if
you're just saying is supermarket type 1 sales same as supermarket type 2 sales or not? Something like that you're testing?
Yeah, outlet type and outlet sales.
You're just taking type 1, type 2, type 3, not the grocery store. 4 types are there. You're taking 3 types.
I took only 3 types: supermarket type 1, 2, 3, and 3.
And you're taking the sales, corresponding sales. Okay, I got it. Yeah. Mm-hmm. What is the result?
So results, all nulls are low, so we have different means for different supermarkets. So basically, I was testing if is there any relationship between mu1 and mu2, or there is no relationship?
Yeah, what it means is each supermarket has its own mean sales,
Yeah.
average sales, which means there is a relationship between sales and supermarket type. So this is interesting actually. If you see, covariance did not find out anything, but if you see the test of hypothesis, then you found out that all the p-values are low, which means none of the averages are same, which means depending on the supermarket type, if you put supermarket type 2 versus type 3, there is a difference in sales. It may be
Yeah.
increasing or decreasing, I don't care, but is there a difference in the sales, average sales, given I started a different supermarket type? For
Yeah.
example, big store versus small store. Maybe small store is getting lesser sales, but here I'm not you're not testing that. You're testing whether the sales are different or not. It looks like it is different.
It is different. So this, of course. So we accept H1 or fail to reject H0.
Right.
Is what the conclusion is.
So depending on the type of supermarket that you keep, the sales will be impacted. That's what you can assume.
Yeah.
I mean, that is the inference. So if you see, inferential statistics is always about the inferences. Now the final inference that you got is, depending on the supermarket type, there is a difference in the average sales.
Yeah.
Not the sales, the average sales. There is a difference again.
Of course. Yeah. Obviously. Yeah. We're testing for mean, which is
yeah. The average sales is different.
Okay.
Okay. So that's what you should see. Just covariance will not give you everything. Covariance will give you something. Inferential statistics will give you some more inferences. Okay, some other descriptive statistics like Curtises or something, it might give you something else.
Okay.
Okay, based on all of them, you have to analyze. One tool is not sufficient actually to understand the data.
Yeah, that part is what I was struggling with. Where to draw inferences from? So
you have to draw from everything.
Okay.
Okay, all of them together. There is no one single one single tablet for everything. If you have any disease, every disease will have a different medicine, right?
Yeah.
Same thing here.
So I went on to test of independence. So I created different cross tables between different.
One thing, let me correct you one small thing here.
Sure.
Here, what you did is mu1 equal to mu2? Then you checked, is mu2 equal to mu3? Then you checked, is mu2 equal to mu3 or not? 3 different tests you did, right?
Oh, right.
So actually, this should not be like this. This should be an ANOVA, right? This is a 3 sample test.
Okay. Got it.
Okay, that is something that you need to take care of. If there is any time there is more than 2 sample, do not go for multiple 2 sample tests. What happens is, across these mu1, mu2, mu3, you are testing mu1 equal to mu2 or mu2 equal to mu3 or mu1 equal to mu3. 3 tests you are taking, right? Each test will have a different alpha. Now, if you want to take a combined, if you take a combined decision that supermarket 1, 2, 3 are having different averages, the decision, final decision, will have a bigger p-value, bigger alpha value than 5%.
Yeah.
Okay, that is called family error rate. That's what I told you, right? If you remember.
Yes, Sandeep.
The family error rate will be higher here.
Yeah, family error rate will be higher, of course.
Yeah.
What my line of thinking is, since I was just doing comparison of 2 sample sets at any given time, I thought we could just do multiple one of them. I think I wrote it down in notes. If it is more than 2, then go to ANOVA. If it is only 2, maximum of 2.
Yeah, actually, but
That's the way I understood it. Maybe I should rewrite the notes.
yeah, here you should take combined, right? The question is here is supermarket 1, 2, 3 are having different average sales or not? That is the question you are answering in this entire block.
Yeah.
Though you did multiple samples, final answer is that one only.
Oh, okay. Oh, that is something.
Okay. Yeah. Okay, you can go on to the next one.
So what is it? I wasn't sure which cross table was the best for us to take cue from.
What was that about?
I create
Location type, outlet size. Outlet size, what is the data type? I'm not sure. I do not remember actually. In fact, I did not see the data set properly. Can you show me the outlet size? Size is large, small kind of thing. So one thing I would like to appreciate is I think you did your own research for some of these Python things, right? Yeah, that is a good thing.
the outlet size.
Okay, outlet size is medium, high, low, something like that. Small, medium, high. Okay, cool. I got it. I forgot actually. I should have seen before the session. Yeah, what is the question here? Is it running or not? One more thing, Zahir, we are getting late. Actually, I planned only for 15 minutes.
Oh, okay. Okay.
Just try to complete it in the next 3-4 minutes, maybe.
Yeah, sure. Yeah, so, okay, I'll just skip through it.
Just go through. I mean, no problem. We still have 3 minutes. Maybe it is 7:13 now. Maybe 9:43 in your time. 9:46 we can close it. I think we still have time. You're anyway at the end, right? This is the end, right?
This is the end.
Okay. Yeah. I don't want to skip this. At the same time, I don't want to delay for Vijay also.
Sure. So I went through different cross tables just to make sure if there was any correlation between the location type, high, medium, small. Grocery between tiers and grocery type. And if there's outlet identifier, if there is any, I mean, I didn't find anything interesting in table 3 between outlet identifiers and grocery
outlet
type.
Identifier. Oh, okay. We may not see. Outlet is like we cannot see. It is more like an outlet identifier. Everyone.
An outlet size and between any fat content if there is anything.
Outlet size and fat content. What did you see here? Okay, that's fine. Yeah.
Yeah.
So we created 4 different tables.
Yeah, I created 4 different tables and I went through different statistics. What I found was, of course, I kept passing different tables to the statistics.
Right.
I didn't know how to pass 4 different tables and come up with a combined analysis. So I kept passing one table at a time. So this is, I mean, what I found is there's definitely a strong relationship between, because we cannot exactly quantify between discrete variables. We can only say whether there's a relationship or not, no relationship.
No, we are still quantifying. So we're still quantifying. We're still quantifying with the confidence level. Okay, that is how we are we are saying, okay, I'm 95% confident that these two are related. That's what we are saying. Our quantification is on the confidence side.
Oh.
Okay.
So the location type, outlet type, and outlet identifier, there is definitely relationship. I did not find any relation between fat content and outlet size. That's,
Oh, okay. Okay. Which means outlet size and the amount of fat content or the fat content items that they're selling, there is
yeah,
no relationship.
I found them independent.
They're independent. Regardless, even if it is small outlet size, they're selling high fat content.
Yeah.
Big outlet size also same high fat content they are selling.
Yeah.
Okay. And location type and outlet type is one more thing. Location and outlet identifier also, is there a relationship? But it doesn't make any sense. How can you?
Yeah, outlet identifier.
Yeah, it doesn't make any specific sense there. Outlet identifier, but at least outlet type and location type, I think that makes
So
sense.
that's why I put them in the beginning when I started
Yeah.
typing. Location type and outlet type, definitely
Yeah.
those would be in relationship.
Technically, outlet identifier, it won't give any meaning for us.
Right.
Right? Yeah. Okay.
That's all I have.
Okay. Any questions you have for me?
My question is definitely, as far as understanding goes, Sandeep, I seem to have bits and pieces of how things work.
Mhm.
What I would like to see is how they all get stitched together. Right? I have some semblance of how they all stitch together.
Mhm.
What I don't know is the last analysis I've written, where you see my screen. Is that where the box stops, or the?
So, for example,
Yeah.
outlet item fat content and outlet size, there is no relationship. It means that can you go down last one? The last. Okay, you're opening it. Okay. Not the identifier. Item fat content and outlet size. So what it means is, here there is no relationship. I mean, whether I'm selling fat content or no fat content, or outlet size is big or small, these two are not related at all. The only meaning it gives me is I cannot remove one of these field. The reason I cannot remove one of this field is because to predict the final sales, my final goal is not the statistics. My final goal is predicting the sales. And to predict the sales, these two doesn't have any relationship. What does it mean? If I remove one variable, other variable will not give you the same meaning.
Got it.
What does it mean by having relationship? If one increases, other decreases, something like that.
Yeah. So I mean, okay. Okay, now I understand. So
Right?
do the prediction with the minimum number of data points. At the same
Yes.
time, you have to ensure that the prediction is accurate.
Yes.
To a certain quantification criteria.
That is one part. Another part is someone may ask you how well outlet size and fat content are related. This may be related to some other business goal, may not be for this prediction at all. Even in this case, you have to do this statistic.
Okay, got it.
Okay, for example, let's say you're a data collector and you're collecting all this data, and outlet size, fat content, all these fields, all these different fields are giving you a lot of problem in storing the data. Maybe one of the engineer may come to you and ask, do you need both the information, or shall I remove one of them? In those cases, what you should say is, based on your first you should go through your statistics, then you should understand about the nature of the data, then you can say to your business saying this field is not needed anymore, you can remove it from your data store or your data warehouse, whatever it is. These kind of decisions will come with statistics.
Got it.
Did I answer correctly?
Yeah.
Or at least to your satisfactorily?
Yeah.
Okay. Any other questions?
That's all, Sandeep.
Okay, overall you did very good. I just wanted, can you go up to the beginning of this one? What you should do it is, even after this session, so there are many fields, right? Like item weight, MRP, okay, sales, and these are only numeric variables. There are some other variables. Can you go to the Excel sheet?
There's some category.
Yeah.
All
So what you need to do is you need to understand the relationship between every two variables or within the variable itself. For example, you can also do what is the percentage, is the percentage of low fat content items that are purchased, is it same as regular fat content items or not? It is a two sample percentage test, or what is it, proportion test, right?
these two items.
No, within the fat content itself,
Oh, okay.
what is the proportion of fat content, low fat content items that are purchased compared to regular fat content items? Similarly, even on the item type, you can do the similar kind of things, right?
Okay. Okay.
Or you
So
can
these
also say what
yeah.
within
Okay.
the item weight and MRP, sorry, not weight, sorry, fat content and MRP, you can ask a question: is low fat content very costly? It could be, right? There is a chance that it is more costly. So
Okay.
these are some questions you can answer with this kind of a statistic.
Okay.
So you can answer more questions actually. I mean, the reason I kept this session is for you to understand what kind of questions you can ask on this data using inferential statistics or descriptive statistics or whatever it is. Okay.
Okay.
Whatever you gave the questions, that is good. You can extrapolate with more questions. That way you will get more understanding about why do we need two sample proportion test, why do we need a variance test. Okay, maybe variance test you can try to think about yourself. For example, if low fat content and regular fat content are having same averages, then the next question is, are they distributed evenly or not? Okay, so those type of questions you can try to find out. But anyway, that is good. Whatever you did, I like it. Okay.
Okay.
Hope you got an intuition about why statistics are needed.
Yes,
But you still did not get. I'm not sure.
no, I got it. But what I would probably suggest or ask is,
Mhm.
um, like for you from like since you deal with advertising and marketing,
Mhm.
maybe get 30 minutes how to quickly run through this and at least the process of like a quick and yeah, like the rule of thumb way. So if you get a data set, how do you quickly go through it? Is the process that I followed. Look at the descriptive statistics first,
So
and
I don't
take.
think it is much different from whatever you did.
Oh, okay, okay,
Only that whatever I do is by looking at the data,
yeah,
immediately I'll try to write down some of the inferences that I think could be true.
okay,
Okay, one of them, like I said, like sales of medium, sorry, sales of low outlet size outlet supermarket
yeah,
is less than medium, based on the outlet size. I'm saying
yeah. Okay, got it.
if the outlet size is small, the sales are small. If it is medium, it should be more. So these kind of intuitions, I'll write it down. I'll quickly, based on the data set, I'll quickly do the statistics, whatever you did.
Oh, okay, okay, got it.
Okay, first I'll write it down. Whatever I think, just extrapolate whatever I can think quickly.
Yeah.
Write down them and then validate them.
Okay, got it.
Okay.
Okay. Thanks.
Okay. Yeah. Thank you. Okay. Great work. Vijaya, do you want to show?
Yes, Sandeep.
Yeah. I'm sorry. I thought it is only for half an hour. Sorry, 45 minutes.
It's okay. No problem.
But if you are free, you can show it now, or otherwise we can schedule again.
I mean, it's up to you both. I can just quickly show you because it's basically the same things.
Okay. Okay. I'm free. You can
Okay.
show me.
Give me 1 second. I wanna wait a minute. So I'll start with the descriptive statistics.
Mhm.
So in the beginning, first I was trying to find the percentiles. So I imported NumPy and Pandas.
Mhm.
Let me see if it doesn't run everything at once.
Yeah, you can run all at once. Then you can show me. Okay, is the data set in the path? I think you should remove one dot dot.
It should be in the.
Yeah, you can run all again.
Okay, so basically, I started with the basics. I did the quartile 1, 2, 3, and 4. And this is the information that I found. Basically, quartile 1 means 25% of the data points are less than or equal to 93.8265. And the same for the other 2, 3, and 4. The
Okay.
quartile 50%, the 3 is 75%, and the 4 is 100%. Then I did a box plot about the item MRP, just to kind of see how the distribution is of the data. And then I use the Plotly to do the same thing. It basically gives you the same information, but you can kind of see the points on the plot.
Right. Yeah.
And then okay. And then here onwards, I wanted to do some find out the mean, median, and mode. So basically, this is all the data for the item MRP. And then I found out that the mean is about 140 and the median is about 143.
So actually, so what does that tell? Do you understand that? If mean equal to 140 and median equal to 143, do you have any intuition about that? Why are they very close or something like that?
Basically, isn't it close to normal distribution because mean and median are equal?
Yeah, it's not normal, but yeah, you can say it is normal, but more accurate way of saying is it is more symmetric. The distribution is more symmetric.
Yeah. And then I did the variance. It basically tells us how far each number is in the set from the mean. And then I found out the standard deviation as well. And then I did the IQR interquartile range, which was 91.82. And it tells us how spread out the middle values are. And then I kind of did the shape of the data, the skewness. It is 0.12. It's close to, not really close to 0, but very close to 0. So
it's a little bit positive skewed, but not much.
Yeah.
So if you see the mean and median, that's what it says. Can you go above? Mean and median are very close, but median is a little higher number.
Yeah, to positive.
It means that it is on the positive side. That's why it is positive skewed.
Yes. And then I did the kurtosis as well, and it was a negative.
Okay.
So it's basically, it means that it's, this one, I forgot how to say it, platykurtic or?
Yeah, less than 3, right?
Yeah.
Anything less than 3 is platykurtic.
Yeah.
Platykatic means it is more flatter than the normal distribution.
Okay. And
That's
then
okay. There is no inferences that I have told you about the curtices.
okay.
So that is okay. You don't have to worry about much about curtices because you know we don't have any inferences about curtices.
Okay.
Okay.
Okay. And then I did some miscellaneous ones with the sum, cumulative sum,
Yeah, these are just to learn the. It's fine. Yeah.
and then count like the number. I think it tells us the number of the data points.
Mhm.
And then let me see. Yeah, and then I kind of just put it in this frame, in a data frame. See, again, it's the same thing about the sales, and then this kind of gave me all the mean, median, variance, standard deviation of all the columns that we have.
Mhm.
And then and then I did to describe the data for the item MRP, and this is what I found. And then this is in a way again in a data frame for all the different columns that we have. And then the same thing that I did, the skewness, the curtices,
So
and then I
hopefully,
did the
can you go up? So there are many, when you say describe, there are many things that are happening. Hopefully, you manually saw all these things, right?
yes.
So one thing is, let's say if there is a item weight,
Mm-hmm.
the count of the item weight is very less compared to other counts.
Yeah.
Do you understand why the reason? What is the reason?
Data is missing.
Yeah, the data is missing. So likewise, you have to see all these numbers basically. So it's not just enough to run this. You have to see manually, understand everything, only then proceed. For example, even if you see the mean and median, always look at mean and median. If they are not close enough, then you should say that you should realize that there is a some kind of a skew. Especially in outlet sales, you have skew.
Mm-hmm.
The moment you have a skew in outlet the sales, it means that you have outliers. So you have to go and remove the outliers, come back to this describe, again do the describe. Okay, you have to make it unskewed. It's not enough just to run this describe and then say I have mean of 79 what is it 2181 and median of 1794. That's not enough. You have to understand why it is different.
Okay.
Okay.
Yeah,
And
so
the easiest way to identify is 75th percentile and maximum are also too much different.
Yeah.
That shows you if you see 25th percentile, 50th percentile, 75th percentile, they are not really dispersed. Okay, 834 to 794, it is not much difference. 50 percentile to 75th percentile, there is not much difference. But 75th to maximum, there is a lot of difference.
Yeah.
Which means on the maximum side, on the right end, which is a positive skewed, it is a positively skewed distribution. Based on that, based on this describe, I can easily say that it is a positively skewed distribution. I have to see what causes the skew and try to remove them. And then see if after removing mean and median are closing on or not.
Yeah, sounds good.
Okay. Just saying so that you don't just run describe and then say I found my analysis.
Yeah.
You have to understand all these things.
Yeah.
Okay.
So
Similarly, standard deviation. I'm sorry to interrupt again. Standard deviation, you see that it is 1706. Now, you need to have an intuition saying, is this standard deviation too much or not? Okay. For that, again, you can go with the 50th percentile. Either the 50th percentile or the median. Either the median or the mean. and compare with this standard deviation with that mean. If the standard deviation is too much large compared to the mean, then you have some problem with the variance also, okay, or the distribution of the data itself. Here I feel it is not very good as well as not very bad. They're very close, right?
Yeah.
If the standard deviation, let's say it is 3000 and mean is 2000 only, then I would start worrying.
Okay. Yeah, there's a lot of difference.
Yeah.
And then I did the same thing, the skewness and the kurtosis, and like you said, item outlet sales is positively skewed.
Mm-hmm.
And then I did the covariance and correlation.
Mm-hmm.
And as Zahir also was pointing out, the item outlet sales and MRP, there's a huge covariance. And then I did the correlation as well. And it seems like most of the variables have a negative association.
But it is very less, so you don't have to worry about it.
Okay.
If it is anything more than like 50% or 60%, you have to start worrying.
Okay. 50% or 60%. Okay.
Yeah. Again, that is not something that anyone will tell you. It's something that it is mostly like, if there is a correlation, more correlation, then it means that it is at least 40-50%, right? Then otherwise there is no correlation at all. For example, establishment year and weight. The first column, fourth row.
Yeah.
First column. Yeah, even that one. Yeah, both are same.
Yeah.
So this is only 1%. 1% negative correlation. There is no use actually. Not really useful.
Okay.
It almost means that there is no correlation. Okay, carry on.
And then I just did the basic count, like you said, to find out where the data is missing. It would be in the item weight and in the outlet size.
Exactly. So if there is a missing data, what you have to do is, maybe I did not tell you, can you create one more cell? I'll tell you what to do. Just run sales dot drop drop na. Yeah, keep a parenthesis. Then say dot count after this. No, after this. Okay.
And run it.
One more parenthesis.
Okay.
You can see.
Yeah, now everything
is same. I'm not sure why it is very less. It is because each column has a different missing values, right? It's trying to resolve all of them.
Oh, okay. Sounds good.
Okay, that's how you should remove. So there are multiple ways to remove the null, missing values.
Okay.
But the best way always is removing completely, like this.
Okay.
So there are people who will say you replace it with mean value, all those things. Those are nonsense. Do not hear them. They'll not work.
Okay.
Okay.
Save this.
I have a question on dropping the missing values.
Yeah.
Don't you want to do the analysis first, whether there's any significance of a particular variable before you use it as a yardstick to drop NA values?
Yes.
First,
so
item might not be significant at all. Using that as a cue for
You're correct. I got your point. So, for example, what you're saying is item weight is not at all useful for. I'm sorry. Item weight is not useful for all your predictions. Instead of dropping the row itself, just drop that column.
Right.
That is also possible. So to drop a column, what you have to do is drop NA. I'm sorry. Sorry for that. So drop NA you can give axis equal to 1. What it will do is it will see all the columns which are having nulls, and those columns it will drop. So yeah, you can try it out. Axis equal to 1 dot count. If you run this, can you see outlet size? I think that is lost.
Yeah.
Even item weight is also lost.
Yeah.
Okay. So for doing this, like you said, you should not do it here. You should do it after all your analysis is done, and after you found out that these are the causes for the these kind of columns are not useful in your analysis. So
Okay.
you have to do, this is an iterative process. This is not a one side, I mean, this will not happen one time. So what happens is generally you'll do first you'll do your inferential and descriptive statistics, find out some variables which are not useful, remove them, then run then try to drop the null values, then again try to do the inferential statistics, then you find some more variables which are not useful or useful. Based on that, you add or remove those variables. Then you do the regression or any other machine learning technique. During the machine learning technique, you will realize that there are some problems with your data. For example, maybe the multicollinearity is more or something like that. Based on that, maybe whatever you dropped, maybe you'll bring it back and put it in your algorithm. So there are many things. It's not one time that you'll do it. All these things, you'll do it again and again.
Okay, got it.
Okay, until you are fine. Until your whatever your goal is achieved.
Okay.
Okay. Goal is, for example, accuracy is high or something like that. Maybe accuracy should be greater than 90%, or your error should not be more than 5%. One of these goals. Okay. Or your variance should be very less. Bias should be more. One of the goal you'll keep. That goal you have to achieve.
Okay.
Okay, I'll move on to the next one, or
Yeah, move on.
Let's go into this. Again, this is just to show you the different ways to kind of present the data using dot head and dot tail. Head will show the first 5 records and tail will show the last 5.
Mm-hmm.
And the shape basically will tells you the number of rows and number of columns that we have.
Mm-hmm.
Again, I just did a box plot kind of to see for item visibility, how number of to show the number of outliers, kind of to get a visualization of the data.
Mm-hmm.
And then again, I just did a histogram, the same thing, just to see how the data is. And then I did the item fat content with value counts. One is just showing regularly, one is with a frame.
Mm-hmm.
And then again, I did the same histogram. And then I found the same mean, median, and mode for the different variables that we have.
Right. Yeah.
And again, mode tells us the most occurring data point. And in the fat content, it is the low fat.
Mm-hmm.
And then, let me see. And then I found the mean when the fat content is regular fat versus low fat.
Not much different.
Yeah, they're the same. And then I just did the value counts again for all of them. And then I kind of found out how many of the stores or the outlets were established in each of the years. And then
most of them are, I think there is an even distribution after 87.
Yeah.
But before 85, I think there is a bigger number.
Yeah.
Okay.
And then I wanted to see if the outlet type was a grocery store, supermarket type 1, or supermarket type 2. with regards to the establishment here, when were they opened? So
What was it? Okay. You're
yeah,
just seeing across the store type.
yeah,
What is the establishment type? Okay.
yeah. When did they open those kinds of stores?
So almost the same. Only thing is, I think supermarkets are more recent.
Yeah,
Grocery stores are all old types. I think anything before the 2000s or 1980s,
yeah,
at that time they were established. All the
yeah.
supermarkets are more recent ones.
Yes.
Okay.
Okay, that and then I'll move on. I'll start with the Z test.
Mhm.
Mm, Okay. Again, I imported all the things that I need to import to run the 2-sample test of hypothesis, and my alpha is 5%. So basically, what I wanted to find out was that the sales of low-fat products equals the sales of the regular fat products. So then what my results were um, is that my test or Z-calc is negative 1.72, and the p-value is 0.08. So when the uh, p-value is high, null will fly.
What is the alpha you considered here?
5%.
5%, right?
So that's why I failed to reject the null hypothesis, which basically means that the sales of both the products are pretty much equal. It doesn't matter whether it's a low fat or a regular fat.
Okay. So here, if you increase your p-value, alpha value, you may get a different result as well. You should be also cautious about that.
Yeah.
Okay, but 5% is more standard, so that's okay.
Okay.
But I'm just saying, like, if alpha equal to 10%, the result is just reversed.
Yeah.
Okay.
But it generally, I guess, stick with 5% for
Yes,
most of.
that's correct. That's correct. And I'm just telling you. I'm just reminding you one more concept. That's the only thing. Otherwise, your results are correct. Okay.
Okay.
Go on.
And I did a t-test. In this one, I kind of wanted to pick different columns, different variables, but I was kind of a little bit struggled with that. So in this one, what I wanted to see was that the, I guess, item MRP for low-fat products is less than the item MRP for regular fat products.
Okay.
And then what I found out was that basically the cost of the low fat products are in fact less than the cost of the regular fat products. Again, my p-value is 0.21, but again, my alpha is
5%.
Yeah, 5%. So the p-value is high, so the null will fly.
Okay, which means low fat content is having MRP. The cost is less than regular fat.
Yes.
Okay, but this is only for the first 20. Right?
Yes.
First 20. 1 to 21, which means 1 to 20.
Yes.
First 20. Okay, cool.
And then
again, in reality, you don't have to do t-test in this case.
Yeah, because
we just simulated the t-test just to show that we can do t-test as well.
Yeah, because n has to be less than 30. So
yeah, in this data set you don't have to, but yeah, you did. Yeah, that's good.
And then I'll go to
chi-square.
So in this one, chi-square, I said that there's no relationship between the type of item sold and the outlet type. Meaning basically, again, I don't know what their definition of grocery store and supermarket type 1, type 2, type 3 is. But in my head, I was just thinking that maybe the grocery store is kind of like a local grocery store at the end of your street, whereas supermarket is, a big one. So I was wondering if the grocery store would carry more of the basic necessities like milk and bread, whereas a supermarket would carry like a wide variety of products.
Yes.
So what I found out was that let me go. Um, what I found out was that there is no relationship. Basically, it didn't matter whether it was a grocery store or any type of supermarket. Like all of them basically carried all kind of products. And even
Okay.
in this situation, the p-value was very high.
Mhm.
So so I failed to reject the null hypothesis.
Okay. I think this one is very interesting. I feel.
Yeah, because I was thinking more like grocery stores would be smaller, and
Hmm.
since they were like most of them opened back in 1985, at that time I would think that you would basically carry the essentials, not like frozen foods or like
Right. Right. Not the packaged foods, basically.
or canned foods or any of those.
Yeah.
But apparently it's the same across all the types.
Okay. That is surprising, actually. Okay.
And then I did two types of ANOVAs. I'll just pick one. Let's
Mhm.
just do I'll do outlet type and outlet sales. So again, in this case, I wanted to see if there's any, let me see, let me go down. That maybe same like what Zahir did, maybe there's a difference in the means between the outlet type and the outlet sales.
Hmm.
And what I found out was that at least like one of the mu's is different.
This is for what? This is for the supermarket types, or one of
Yeah,
them means supermarket type.
supermarket types. Yeah,
The
basically.
sales. Okay. The average sales is different for at least one of the supermarket type. Okay.
Yeah, into outlet types. Yeah.
Okay.
And I found out that in fact that at least one of the outlet types mean is different with
Mhm.
regards to the outlet sales.
So then you went with Tukey test.
Yeah, Tukey test. And what I found out was that basically if that all the mu's are different, basically the means for all the different outlet types are different in comparison to the outlet sales.
Oh, okay, okay. So each one is different. The outlet type, every outlet type is going to give a different sales.
Yes, a different mean. Yeah,
Yeah, different mean.
yeah.
Okay.
But what I really wanted to do was I didn't know how to do this.
Mhm.
Uh, like with outlet sales, I was assuming that outlet sales refers to the sales, the complete sales of the the whole outlet type. Now, some stores were opened back in 1985, 1998, or way back there. So I was thinking maybe the longer the store has been open,
The
the
more
long.
trust they build and the more sales they may
Yeah, but then I didn't
have.
know how to do that comparison because it's the establishment year. I didn't know how to divide that up.
So what you can do is you can create a new column.
Okay,
Stores established before the 2000s
okay,
and stores established after 2000s. You can
okay,
create another column. That is a good idea, actually. So what you can do is you can create a new column saying maybe is the store created before, established before 2000s or after 2000s, 1 or 0.
okay,
Anything less than 1985, 2000s, you say 1,
okay,
otherwise you say 0.
okay.
Now this 1 or 0 it's not a really number, it's actually saying whether it is an old store or a newly established store.
Yeah,
Now based on this you can do a 2 sample mean test on the sales.
okay,
Can you create another cell? We can try it out. It's a good idea, actually.
okay.
So what is a variable? What is the data frame variable name?
Let's see.
Is it
Out-
type?
yes,
type is the data frame name, right?
Yeah, outlet type. Oh,
Okay.
no, I want to do outlet sales and establishment year.
Establishment year, right?
Yeah.
Yeah. Can you copy that outlet establishment year? We'll not remember otherwise. Just copy it. Yeah.
And then the other one, outlet sales.
No, that will get to later. Come down.
Okay.
Or yeah. Just type in type
Mhm.
in square brackets. Start a square bracket. This will be in quotations. Right. Single quotes, I believe. Anyway, both are same, I think.
Okay.
Greater than less than 2000.
And run it?
Yeah, just run it. You're getting true or false, right?
Yeah.
So what you can do is anything less than 2000, just click on that cell again, or let me just give me the control. I'll do it.
How do I give you?
I requested. You'll get. You just accept that. Did you give it?
I didn't get anything. Hold on, let me maybe minimize it.
You
Oh, here, yeah.
you declined actually.
Okay. Did it come now?
Yeah, now it can.
Okay.
So what I'm saying is new. I'm creating a new variable name.
Okay.
It's called is new.
Okay.
Okay. Type of is new equal to, I'm keeping it as no. By default it is no. If it is greater than 2000 establishment year, I'm saying yes. Type of establishment year. Okay, not like this. 1 second.
Okay.
Just give me a second actually. Okay. So here there is something called, did you import NumPy? I'm not sure.
Yeah, I should have.
If it is greater, then say yes. Otherwise, say no. And what I'm saying is, okay, NP is not there.
Oh yeah, no.
Let's import, no problem. I just suddenly forgot about this np.where. I was just thinking, what is it? Okay. Now, if you see your data frame, you can definitely see the new column.
Yeah, just to the right.
Is it there? Where is it?
Yeah, all the way to the right, the end, at the end.
Okay, somehow I'm not able to see it.
Okay, it's there.
Is new. Yeah, I can see now.
Oh, yeah.
Okay, you created a new column like this, and now you can do a 2-sample test, right?
Yeah.
Is the sales good at the new stores or in the old stores?
Yeah.
Where old stores are defined as any store which is established before 2000s.
Mm-hmm.
Okay, this is called feature engineering. Actually, I have introduced a little to you.
Yeah.
If you remember this.
Yeah, yeah, I remember.
So feature engineering is very important technique, but this is not statistical. I cannot teach any statistically proven methods to create a new feature. It only comes from your intuition, like the way that you got it.
Okay.
That the question that you got, right? It is a
Yeah.
natural way. Is the store if the store is very old, is the sales good or bad based on the I mean, whether the store is old or new?
Yeah.
Okay, these are something that you have to figure out yourself. This is something that I cannot teach. At least I got a chance because you gave me that hint.
Okay.
Okay, when you're doing feature engineering, you're creating new variables from whatever variables you already have. Maybe I can say, maybe let's say, fruits and vegetables and meat. I can combine them, both of them, as edibles or perishables, whatever it is, and then see based on that, am I getting any improvement in my predictions? So if you ask me what is the way that I can improve my predictions, either in regression or logistic regression or any other future techniques I am going to teach, what you have to do is you have to analyze the data. Based on the data, you have to analyze your algorithm. Then you have to create these kind of new variables. These new variables will give you more power. These new variables will give more power to your data science algorithms, your predictions.
Okay.
Okay,
Okay.
thanks for that. Actually, I did not plan to give feature engineering class, but I just gave a small introduction at least. Thanks for that.
Yeah, no problem. Sounds good. I will run, like you said, I will do the 2-sample test,
Yeah,
and then we'll kind of let you know what I got the result is.
you can create more. For example, maybe fruits and vegetables and soft drinks. You can combine in some way and
Okay.
then create a new variable, something like that.
Okay.
Always there is a scope for creating a new variable.
Okay.
I'm not able to correctly give an example here, but at least I think you got the idea.
Yeah, yeah, I got it.
Okay.
Okay.
Okay. Anything else? I think you have another ANOVA example also, right? You can show it
Yeah.
in maybe next 2-3
Yeah.
minutes.
Oh, yeah, yeah, I can do that.
Yeah.
So, like I said, I was trying to use all the variables that I can with everything instead of
Yeah.
running the same test in the same variable. So,
Yeah, that is a good thing. Yeah.
and so in this one, what I did was I did a location type and outlet sales, because in the location type we have tier 1, tier 2, and tier 3.
Mm-hmm.
So I wanted to see if the outlet sales or the mean outlet sales for each of the location types is same or different. Even in this case, my conclusion was that at least one of the means
Are
mean,
different.
are different. So then I did the 2-key test, and then I found out that the mean of tier 2
Mm-hmm.
is equal to the mean of tier 3. But tier 1 does not equal tier 2, or tier 1 does not equal tier 3.
Oh, okay. Okay.
So basically, the only two mu's or the sales
Tier 1
But
and tier 2, it's a tier 2 and tier 3 are different. Sorry, are
tier
same. Sorry,
same. Yeah,
they are same.
yeah. So
Okay. Okay. That's good. Looking good, actually. Do you have any questions?
no, I don't have any questions. Only the other one, which I'll try to do it now that you gave me a little bit of idea of how to do it. So
Yeah. Yeah. You can. So the possibilities are infinite. You can see, right? If
yeah,
you keep on trying something, maybe tomorrow. So now you got another variable. With that variable, maybe there are other combinations that are possible. If the store is new, as well as if the store is selling fat content or not, if the store is selling the kind of items that the store is selling, or the sales of the new store versus old store. Now you got a new dimension to the existing problem. Again, you have to do all those kind of combinations. Maybe during that time you may get some other idea. So the possibilities are infinite, and that is the difficulty in this course. Actually, the difficulty is not in the mathematics, it's not in the the Python language. The difficulty is in identifying the infinite possibilities. Out of those infinite possibilities, what is the best approach I have to start with? So that is where the problem starts with, actually. Hope that is clear.
yeah.
Yeah. So Zahir, do you have also any questions, or are you fine with the existing discussion?
I'm good, sir.
Okay, hope you got good idea about how the statistics can be used. So if you still have any questions, you can still ask me. But I
I,
feel this is a good way to explain you the concepts instead of me going through the real data set. I thought, I mean, since I have given you the enough knowledge about it, how to approach and all, but all I have done is bits and pieces. But what I wanted you to do it is, I wanted you to go through everything and then fill up the gaps. Okay, I have explained in theory how to fill up the gaps, but I have not shown you in a one data set how to perform all these things. I have shown you in different data sets. I think after this one, it should be clear for you.
yeah, this actually doing this helped me kind of, instead of just listening to what you were saying, this kind of made me think on my own and kind of actually understand why exactly I'm doing this rather than just,
Exactly. So
understanding.
if I explain even 10 more data sets, the 11th data set, you'll get the same questions.
Yeah.
So unless you put in your hands, it's impossible that I can teach you 100%. So hope this is helping you. I'm planning
Yeah.
for one more project. I'll see which one to pick up.
Yeah, I was thinking if we can do one more like with regression, that would be helpful because I
Yeah,
feel like regression is a lot more than.
yeah. Probably you can do the same thing on regression, but
Okay.
I'll see the best data set, if this is the best data set or not. I have not applied regression on this.
Okay.
I'll try to apply myself and see if it is a real value or not. I have never used this data set. I used to use some other data set.
Okay.
This is a data set. I got it from internet something. This is a real data set, actually, Big Mart. It is one of the supermarket chains. They did this analysis. I mean, they had this data, actually. Okay, I'll see if regression is uh, how uh, how likely regression is going to work on this data set, actually. Okay.
Okay.
It's going to work, but I'm just trying to figure out if it is straightforward in your application or not. If it is not really straightforward, maybe you will not be able to figure out the challenges. I'll see the best way. Okay, so that's all I have. Any further questions?
And then fundamental to what we just said, would it be possible? Would it be possible to pull in the class times by 45 minutes?
I did not understand it all. Your voice is not at all clear.
No, I was asking, would it be possible for us to pull in the class time by 45 minutes?
The next one.
No, going forward, because well, what is going to happen is for the Eastern time, I'm settling between Eastern and Mountain time on alternate week basis.
Mm-hmm.
And if when I'm in Eastern time, it becomes really difficult to do that 9 Eastern to 10:30 Eastern. I'm okay when I'm on the Mountain time.
That one I'm not sure, because one more thing I wanted to tell you. So last time the previous times I taught only 2 hours. This time I'm only teaching like 1.5 hour.
Yeah.
And because of that, the class got extended already. If you see, it is close to 4 months, and we are at the beginning, or at least maybe 20% of machine learning is done, roughly. So machine learning itself will take more time for us. So if we pull in class time, we are going to delay it further. That's the only thing. That's, if you are okay with it, we can do. The other thing is, even I started using Python. Python itself, I think at least 7 to 8 days is lost for Python, for getting you up to speed on Python. Last time on R, I did not teach that much. I think only 3 classes or 2 classes. So all these things added up, and because of that, the class got stretched. So I'm just feeling that I'm not sure. Are you feeling it is too much stressed?
No, Sandeep. What I'm saying is, instead of starting 9 o'clock Eastern, can we start a little earlier? That's my question. I'm not asking you to add more sessions.
Okay. Which classes? The regular classes or this one?
Regular classes. Regular classes.
Regular classes at what time you want?
Can we start a little? My question is, can we start a little earlier?
Early might be difficult for me. Sorry for that. I cannot do that.
Okay.
Okay. Yeah. What I was saying is, about the class, it is already. I think I told about 3 to 3.5 months. Now it is already 4 months, and it may get closer to 4.5 months, something like that. Okay. So that is something I wanted to tell you.
Okay. Yeah, that's fine, Sandeep. We'll just play it by the ear and see how it goes.
I'm sorry?
No, we just take it as it goes. That's fine.
Yeah. So at least I don't want to push it quicker. Telling the course in a faster pace, it is bad. It's always better if it is, even if it is slow, it is okay. But at least you should be able to grasp the concept. That's what is my way of teaching, at least.
Yeah, no problem with the teaching.
Yeah. So yeah, that's all I have. Do you have any problems in the classes or the way I talk or whatever?
I'm okay, Sandeep.
Okay.
Yeah, I'm okay too, Sandeep.
Okay. Yeah, probably we'll plan another session for regression and any machine learning technique. We'll see how it goes. Okay. Thanks for joining. Sorry for the delay as well. I thought it is 45 minutes. It's close to 2 hours. Okay. Sorry for that. Okay then. We'll catch up tomorrow then. Bye.
Bye.